Hi everyone, we're back.
Hey, we are back, and it's only been a week.
It's only been a week this
Yep.
time. That's it.
Oh, it's a miracle of miracles.
Look at us. We are on our way to being pro streamers.
Let me see. How do I open up the? There's like an moderator view, isn't there for Twitch?
Yeah, there should be
Oh,
a mod
Yeah.
view.
I just found the button for it, guys. Don't worry.
Nice.
Yep.
Good job.
Congratulations.
Definitely
Welcome
know
to
what
being
I'm
a mod.
doing.
It's another step towards the pro streamer.
All right.
So this
What
week
do we?
we're doing another Vulnhub. It is called HackerKid, so we're going to get our HackerKid on. And let's dive straight into it, I guess. We start off, as we always do, with Nmap, with our safe scripts, enumerating versions, and we come up with a few different ports to what we would normally expect to see. So we've got a DNS port, which means that this host is running a DNS server. We've got something on port 80, which we kind of expect these days with CTFs. There's always a website as the way in. And something on port 9999, which reading the header, it's another sort of website, but this time running on Tornado server, which I had never heard of before coming across this box.
Yeah, it's
So
a Python.
it should be a fun one to have a poke at. But as always, we'll start with the website. So head on over to, that's the wrong one, that one. We've got our proxy running in the background, just so that everyone knows what's going on, so that we can log everything that's happening just in case we come across something interesting and we want to replay it or look at it again. Clicking around the app, nothing really seems to happen. So, oh, actually, apparently that breaks it. So that's always fun. Since it's a website and all the links that we can see on here don't really do anything, we're gonna come across to our good friend GoBuster. I should really do that target IP thing so I can just copy paste stuff from the write up. But that looks legit, so we're gonna run that. It's our standard GoBuster that we always run with our dirbuster medium word list, and just because we can, we're going to chuck a few standard web server file extensions in there too. So we let that run, and while it does its thing, we're going to take a quick look at the source code for the app. So if my F12 button, hello, F12? Oh man, that's running slow. Come on, don't do this to me.
Slow computer is slow. Wow.
Slow computer is very slow tonight. Jeez. Oh shit, just ignore that one.
Just because GoBusters is going mental in the background.
Yeah, probably.
Oh yeah. Forget about that.
Just ignore that one. That's not supposed to be like.
Yeah. This is on a server you prepared earlier, isn't it?
Yeah, definitely. So looking at the, come on, debugger. We can take a look at any JavaScript or anything else that might be running on the site. There's nothing too extraordinary in the JavaScript itself, but looking at the application code, the HTML, holy shit, that's slow. Sorry, is this a family stream?
No, I think it's set to over 18 only. So,
Okay, good.
so it's all right. It's all right.
It is probably easier if I just look at it through the Control U. So this,
I can tell at some point you've done a lot of front end dev because you refer to this as the application. Whereas for me, having in the past done more back end dev, I go, no, this is just the pretty front end.
I mean, you never know. It could be anything. Who knows? We don't know what it's written in yet. It looks like static HTML with
Oh
some
yes,
stuff.
this probably is.
You know, we've been getting an index.php in our GoBuster, so you never know what it is. Anyway, looking at the source code, we see there's a few sort of code comments that do some interesting things. not really. That doesn't really do anything. And then down the bottom, we see that there's a to-do to use a get parameter for page numbers. So at the moment, there's no get parameter. Well, there's a what are those called? Anchors for just the HTML that it's rendering.
Yeah, the fragments. It's technically like a comment. It's not passed to the server. It's only viewed. I think it just means that front end code can access it, but back end code it doesn't get sent to servers.
Yeah.
Yeah.
And so lucky for us, we don't need to try and guess what this get parameter is because they've told us it's page number. Because it's called page number, we're going to assume that it takes numbers. And we are going to generate a list of numbers. That can just die because I don't actually need that. There's nothing useful in the GoBuster, just so that you know. We just run that out of habit. And so this is a really basic bash for loop that's going to count from 1 to 5,000 and echo that into a list.txt. So we'll let that run. It's super fast because bash is super fast. And now we've got a list.txt that's filled with 5,000 numbers.
Oh, hey, Grub.
Hey, Grub, I don't have chat open, so...
I have chat open. Don't worry. I'm on it.
Grub's on time. Look at that. He gets to watch the whole box. So yeah, because we are dealing with a query string parameter, rather than use GoBuster, we're going to use wfuzz because I actually kind of like wfuzz over GoBuster. And yay, it's remembered. So the basics of this is we're going to start off by not hiding anything just so that we can see what's going on, because that's what you'd normally do. We're passing in our word list, which is just our 5,000 numbers, and we've added our page number query string parameter. And anything that from this word list gets replaced with this fuzz keyword, because it's a fairly simple, straightforward, single replacement.
And for reference, the backward slashes are escapes.
Yes, the backward slashes are escapes, just because
Bash would look at that and try and do something with it. Yep.
Yeah, exactly. So when we run this, we notice that a lot of the numbers have a character length of 3654 or a word length of 279 or whatever L is. What's that one? Just number of lines, 116. So we could hide any number of these because we know that looking at, say, question mark page or query page number 1. Oh, it's page underscore number. We just get the exact page that we have been looking at. So we've got some sort of extra info, but we can see that there is something hidden in this page number, but they all have the exact same response, which means they all have the exact same response length, except that wasn't supposed to, that was just supposed to be a 2. Thanks, autocomplete.
Autocomplete, the death of the, not death, but the pain in the ass for people trying to do these things.
Exactly. So we add our --HH. So HH is hide characters. We could hide words or lines or anything else. I don't even know why I picked characters, but I did. So we add that we want to hide anything with that many characters. And now when it runs through, we can see straight away that a payload of 21 returns more characters than every other number. So
I mean, this is actually, in terms of the gaminess of CTFs, this isn't a bad way to do it. Like if normally you'd have to GoBuster a directory and you'd find files in there and you'd have to make sure your file was hard enough to require the right GoBuster list, but not so hard that it takes forever. This isn't going to show up in a GoBuster unless you start GoBustering the actual query parameters.
Yeah, exactly. Which is like you don't normally do. So now, reading the contents of the website, I probably should have gone over that a bit earlier, but it keeps highlighting this word dig. And if you're familiar in any way with, I guess, pen testing or network
Deep
security or
or
DNS,
networking.
you will have heard of a tool called Dig, which relates to DNS queries. And with port 52 or 59 or whatever it was,
53, mate.
my memory is shot today. With port 53 on running on the box, we can safely assume that it's also a DNS server. So all of these dig references are telling us to do something with DNS lookups. And then looking at our page 21, there's even more hints towards that. So we're getting told one of the subdomains for this site. So now that we've got all of this information, we are going to jump over to Dig and see what kind of information we can get back. So first of all, we're going to just dig the IP address and see if we get any useful info from that. And the thing for that is that at that, and we don't want to do that just yet.
So so the format is just, so that's just going straight to the DNS server, and just, it doesn't really tell us much, because that's just going, hey, DNS server, are you there? kind
Pretty
of.
much.
In at least, because you're not actually querying the DNS server for anything. It's an empty query, so you get an empty answer back. The interesting one is that opt sudo section with the cookie. We went off for a bit going, is that like a web browser cookie or something? That whole sudo section's a whole part of it. Extended DNS, which includes something called cookies, which bit of a false friend, a bit confusing, but completely unrelated. I don't know whether it's just whoever set this, that, or the guy who set the CTF up enabled that, or it comes enabled by default. But
Yeah.
that,
Yeah, we
yeah,
did actually start trying to use that cookie around sites to see if maybe it bypassed a login or did some fancy
yeah,
stuff, but it turns out it's just a DNS thing, so
yeah.
it's fine. So yeah, we've got, at least we know that we've got a DNS server that we can query, and we've got a subdomain that we know should be running on this box. So now we're going to actually query that domain and see what info we get back. So here we get a little bit more info, so we can see that the top level domain is blackhat.local, which we could have probably guessed. And there's also another subdomain called HackerKid.blackhat.local. Now that we know that there's potentially a bunch of different subdomains on this box, we're going to do a zone transfer to see if we can get all of them. And we do that by going dig, and we have to use the top level domain for this, so blackhat.local, and the AXFR is the command to try and perform a DNS zone transfer.
Normally, zone transfers, like a sensible admin would have configured their DNS server to require authentication for zone transfers. So normally, if you have multiple DNS servers, you'd only update one and then use zone transfers from the other to pull them over. But they do tell you everything about a particular domain zone or DNS zone. And so bit of a risk if you allow them to be freely copied. Sure, people can sit there and brute force all of the records, but if you've got internal company DNS and external DNS on the same DNS server, which some places do, you don't want zone transfers
Yeah,
being enabled.
it's
Yeah, which
incredibly rare that you'll
by
actually need
default,
it.
I think zone transfers with bind are not enabled. Like you've got to, I think there's most of them by default disable unauthenticated zone transfers.
Yeah.
Yeah. Anyway, onwards.
Anyway, so our zone transfer works, and as you can see, it kind of gives us all of the subdomains that are on this DNS server or in this zone. And we can see we've already got our hacker one that we found. Oh no, that was hackers. So we've got two. We've got hacker and hackers. Then we've also got our hacker kid. We've got some mail stuff. We've got some FTP stuff. We've got a bunch of others that we don't actually really care about.
Yeah.
And so what I went and did from there was add all of those to my hosts file, because we've seen in the past that the way that Apache works is you can have virtual hosts, and depending on the URL that's actually passed in, it can redirect or create different websites depending on what website you're trying to access.
This is how a lot of those like web hosts work. Like they'll
Exactly. The shared web
like,
hosting.
yeah, shared web hosting. So they'll on the same server you'll have like 10 different websites, and it's all done on domain name and virtual hosts.
Yep.
Nginx has a similar thing.
So I've only got
Um,
those two, but that's all you need.
yeah.
In the end, that's all you need. So,
In the hosts file, it's IP address and then host name.
yes.
So if you're doing it development at home and you want to like be able to hit your server with a domain name, you can do it on Windows too. You just find the hosts file and add the IP address and then the domain you want to resolve to that IP address.
Exactly, yeah. So we can see that browsing to hackers.blackout.local just brings us back to the same website we were at. And now we want to try the other one, which is HackerKid.blackout.local, and we get a completely different website, which is kind of what we expected. This site looks like we have to try and create an account, and once again, this is where we sort of tried playing around with the cookie and seeing if maybe we could bypass this registration or access an existing account, but that was all pointless in the end. So let's just type some... Why is that the autocomplete? We're just going to dump some dummy data in there. None of this makes any difference, and a massive epic password. When we click register, we get a little error message that says our email address is not available. Playing with the validation, it doesn't actually care what we pass this. So that makes us sort of wonder what validation is happening. So we look at the source code for a bit, and we look at our requests and responses. And we notice that it is actually posting to a /process.php, and the content is all XML. And straight away, I think we've done some XXE in the past, but whenever we see XML, we sort of start to think about XXE, which is... Sorry, you go.
Oh, you go. No, you go. I don't remember what the acronym stands for.
It's XML external entities or something like that. Something to do with external entities. Which is basically sort of adding variables to the XML, and we can use those variables to include local files or sort of anything that we want. So looking at that, we can just go straight to examples and pull any of these. Oh, right, hang on. Let's just turn that off for a sec. I don't know if any of these actually give us an example. But anyway, that's a standard XXE example that we found online somewhere. There's a link in the write-up to where we actually got this one from, but it's pretty basic. So all we're doing is a replace. This is our variable name, so example, and this is the text that we want to replace with our variable. So you can see here that they're just saying the last name is example, and they want to replace that with the word dough. So we are going to do exactly that, but in our XML, because it looks different. So we're going to send that over to repeater with Control-R, Control-Shift-R to jump over there. And because the website itself, or the web app itself, is outputting the email field, that's where we're going to stick our variable. So we don't really care about any of that. Oh shit, actually, that was the wrong place to do that. We're going to dump that there, and then go here. It's not dollar in this, it is ampersand. example. My mic is in the way of the keyboard. So we send that, and we can see that our XXE has worked because it's replaced example with the word dough. So if we didn't have that, we would expect it to just say the ampersand example stuff.
So for clarity, we're working with that first captured request we did.
Yes.
Yes.
So now that we know that we've got some XXE injection potentially in here, we can add a system call or a system attribute, I guess you'd call it, which is instead of just replacing the string, we're going to replace the contents with a file from the file system. And like we always kind of do to test this stuff, we are going to look for the password file. So we have to escape our slashes here. So we're going to do 4 of them. No, 3 of them. No, they're not escaped. That's the protocol. File protocol and then the extension. So done. Now when we run our payload, we can see that it's replaced our variable with the contents of this local file system. So let's just kind of steal that and see what might be on there. I mean, we don't actually have to copy this anywhere. We can just read through it. So basically anything that's 1,000 or more means it's a user on the box. And we've only got one of those, which is the Sackit user. Sackit. I think that's how we pronounce it.
I'm not going to argue with you.
Cool. There's nothing else too interesting in here. So we're going to keep sort of using this as a way to poke around the box. But because we're dealing with stuff over the web and URL encoding and all that kind of thing, what we can actually do is use a base64 encoding, which will let us kind of copy across anything that we want in base64, and then we just decode it. So to do that, we just let me steal all of this. So what this is doing is basically just running a PHP base64 encode on whatever local file we want it to. And for some reason in the write-up we named it that. Let's name it back to example. So now we know that there's a php.info file, an index.php file in the web root. So we're just going to try and pull that and see what we get. And that didn't work because why didn't that work? Because it's missing that. Okay, we need to update the write-up to have that in it. Nope.
The old no plan survives first contact.
That's it.
Or there's no demonstration like a live demonstration. Just wait while Jake debugs the issue or his issue. I mean, Jake's got a lot of issues, but
I have lots of issues.
So is the challenge with like copying and pasting from notes is that something breaks in the copy paste?
Yes, that is what has happened.
So Mark, while we wait, how's your day been?
It's been a good enough day. I was just thinking, with that, did we actually have that index.php that we looked at, because I didn't have an example where I did pull out the index.php, which I think that was an example that I just pulled off the web,
Yeah, then
which might be it doesn't work.
Oh, hang on. Yeah.
Yep.
Because it's a different
So
web app.
yep, yeah. So possibly that.
Oh, not
Um,
That's why. That's probably why the variable name was different as well.
yeah. Like when you saw the variable name different, I was
Yeah, there
like,
we go.
I'm gonna say,
Okay, that's why. That's what was going on. That makes more sense.
for reference, there's like 3 different approaches we always end up taking. Jake will do it, I'll do it, Mark will do it, and then the write-up we have is based on an amalgamation of all our notes together.
Yeah.
And so sometimes we'll just go, here's something I found on the web, we'll paste it without ever going, oh, by the way, this is how I changed it. Like, this is what I changed to work. It's just like, okay.
But yeah, now we can sort of see that when it can find a file on the file system, we get a bunch of base64 data, which Burp is kind enough to automatically decode for us. And I mean, there's nothing useful in the index.php, but we can use this to have a poke around the file system and look at whatever we want or whatever we have access to. I couldn't be bothered doing that manually individually, so I actually stole a LFI cheat sheet and dumped that into an intruder sniper attack. So let's do that.
So that basically he grabbed a massive list of paths to look at on Linux boxes, fed that into Intruder is basically a way of changing variables in requests.
Yes.
Again and again and again and again. So it'll make a request, change the variable, make next request, and give you back whatever it got. So it's similar to WFuzz or GoBuster, I guess.
Burp needs a bigger font. It does, hey. It's pretty hard to read. Yeah. So, sorry, talking to someone through a different channel that isn't text, Twitch chat. So we're going to add a variable, which that's basically the part of the request that we're going to replace. Sniper is a single variable attack, so we only have one place that we want to attack anyway, which is there. And this is where our payload goes. So this is going to be, actually, I need to change some of the data. So I'm just going to quit that because we don't actually care what that is. Vim, let's go, I don't know, lfi.text. That'll do for now. So this is the list that I stole from somewhere on GitHub. And in here, there were some references to like home directories and the root directory and stuff like that. But we know that I should have probably shortened this list to do the demo, but I was not prepared. So we know that we're probably not going to be running this web app as root. So we're just going to replace this with /home/secit. Because we know, or if I can type that right, we know that Sackit exists as a user. And awesome. Now, to save time, I'm just going to cut those ones and paste them in, and we can see that that did not work. Fuck you, Vim.
There's a particular command to copy out of Bash. Control-Shift-C, I think.
Yeah, that's what I just did, but I think it's the selecting in Vim.
It might be something else entirely inside Vim you have to do to select and copy. I forget.
Yeah.
It's like the problem with Vim. You stop using it, you lose it super quick.
That's it. I'll just do it like that. It's fine. So now we've got quite a short list because we're using Community Edition, which comes with Kali. It goes through these lists quite slowly. So I actually set this up during my lunch break and then came back at the end of the day It was easily done because there's not actually that many in this list, but it could have taken a really long time. Yeah. The attack's going to take a while. So this is very similar to our WFuzz. We are just kind of replacing the request with all of the stuff in this list. And again, we can take a look at these response lengths or statuses and try and figure out what's going on, except that kept root. Hang on, I copied the wrong section. It's like, that's not supposed to happen. Oh shit, it is
Yeah, I
actually
guess
a big list. Where's my second stuff?
I guess it wouldn't be too hard to maybe write a Python script that does the same thing as Sniper, but far faster.
Yes,
But
I'm sure
I guess
there is.
the advantage of Burp, especially for people more at the beginning end, is it lets you kind of play around with some of the concepts around like brute forcing a discovery without actually having to know how to write scripts inside and out. Not that it's really that hard, I guess.
Oh, there it is.
Did you save it after the last changes you made? Oh, yeah, it's there.
Okay, it's actually in the list this time. And we're not going to URL encode characters either. That's a mistake that we often make with the sniper attacks.
All right.
So this time, now we can see that some of these files are existing on the file system and we're getting a different content length. And that's because it's going to include the base64. The interesting ones that we care about are the ones in the Sackets home directory. So things like our bash history or our bashrc file. And because Burp isn't kind enough to give us an automatic base64 decode in our intruder attack, we're just going to copy that one into repeater. Replace that to here. Boom. Oh, it's not Shift V in in Burp. There we go. So I basically spent a while looking at all of the different results in files and logs, and because there's like all sorts of things in all of this, just looking for some sort of secret, and eventually this the bashrc file includes some interesting comments at the bottom. So, well, actually, it's not even a comment. It's setting some variables for a username and a password. So we are going to steal those and save them for later. VM creds. Cool. So we've got some creds. Now we just need to find somewhere to use them. And that's where we basically we could, re-go buster this website and try and look for a login form and do all that kind of stuff. But eventually we figure out there's not really anything else left on the Apache, like the port 80 website. And we start to, if we just look back at our nmap, we start to look at the website that's hosted on port 9999. So why did you Google search that? Because I typoed it. Oh fuck, it's kept the cookie, hasn't it? Of course it has. Okay, this is what we're expecting to see. We're also no longer logging that, so we want to turn logging back on. Alrighty. Now that we've got a website with a login form, again, we ran the standard enumeration stuff in the background, but there's no need because there's no need for this demo because nothing actually shows up from it. We try the creds, so we try admin and the password. Oh, I don't care that it's HTTP. And we've got something's wrong with our data, so that's probably not the right password. We found this in the Sackit directory, so we try Sackit and the password, and we're in, kind of. So now we get a page that just tells us, tell me your name, buddy, and how can I get to know who are you?
All right.
And this is where I kind of took a break from the box for a bit, and Mark actually came up with or found the next steps for this. And that was basically by looking at, so we've got our headers where we know that's running a Tornado server. So we did a search exploit on, the version 6.1 for Tornado and all that kind of stuff. And we didn't end up finding anything useful there. But what we did find when we just Googled for, say, Tornado server exploits, should come up. We find that it's vulnerable to things like server-side template injection. So I'm pretty sure, is this even the link that you went to? Yeah.
Yep, that's the one that I used.
Nice. So yeah, this kind of gives a bit of a background around what's going on, but basically it's a Python web framework that uses templating. And when it's talking about tell me your name, it's actually asking for a name that it's going to pump into a template and then output back to us, which is almost exactly what this pseudocode is giving us back as well. Go away.
Yeah, so for clarification, what it's doing is server-side, it's rendering the HTML before sending it back to you, before sending it back to the web browser. And when it does that, it goes through and basically does a whole bunch of fancy string substitutions on stuff in the template. So if you don't do filtering properly, so this is where I think Flask and Django, which also have very similar templating setups, I think they're also both Liquid, or that kind of same genre of doing templating. They both have on by default filtering to stop people doing what server-side template injection, which is what we're about to do.
Yeah. So it's told us about telling us its name, and then, we've got this basic template that talks about using a name variable and all that kind of stuff. And we're pretty sure they've followed this exact thing as a setup. But anyway, we add a query string parameter for name and just give it any value just to see if that's what this thing's doing, and we can see that it is. Now that we know that, we can continue reading on, and we see that anything with double squiggly brackets is going to be evaluated. And so, we can do these examples, so we can just pass it in. Instead of those guys, we'll pass it in 2 times 2, and it says hello 4. So we know that the code that we put in here it's actually evaluating, and it says that it runs Python, so we can put Python code in here. And this is where we end up with, hopefully, trying to turn this into a shell. So we do a similar thing. We, keep following through our little, I guess, tutorial on how to perform SSTI. And we're getting the same results all the way through. So this one's just running a standard Python command for who am I, and we get the result of Sackit.
Well, it's running os.popen, which is just where Python can open a process, get the process's output, and then it returns it back. Yeah.
So it's running the who am I command on the server and then returning the output of that back to us. And from that, we get to find out that this application is actually running as the Sackit user, not as www.data or anything like that we might expect. Then from here, I don't think this actually went through the reverse shell process. So this is where we got ourselves.
I spent a bunch of time beating my head against the wall because if you just try and stick a straight netcat, you run netcat, a listener on your server, and you try and tee netcat up with bash or any of the other variations that exist, um, it just refuses to connect. And so popen does something with, I think as soon as it gets some response back from the binary, it just closes the process, or it's tornado the server doing something in the background. So it got a little bit tricky to try and get it to work properly. But system, or what's the other one? It was system we'd used, wasn't it?
Yeah. So so I couldn't get just a one-liner reverse shell to work in the URL. So what I ended up doing was, because we can just run any bash command and we don't really care about the output. So I looked and we can see that it's got PHP running, which we kind of knew from the Apache server that's running over there. And we know that we can run a PHP file directly from the command line. So we just went back to our trusty rev.php that we used last week, or the week before, whenever we last used it. So I'm just going to copy that to here, and then cat rev.php. So this is a fairly standard, just PHP reverse shell, really. Dump your IP address and your listening port in there, and everything else will take care of the rest. But now what we need to do is get that onto the server so that we can execute it. And the way that I did that was with our, again, standard file transfer method, which was just a Python 3 simple, well, it's the Python 3 version of a simple HTTP server that we used to use. So now that that's running, it's hosting everything in this directory on port 8000 on my box, and we can now dump in here, instead of which PHP, we're going to wget 12.168.1.162, I think I am. Let me double check that.
Don't forget to add the %22 back that you deleted.
It'll do it automatically. It's good like that.
I think in this case, because it's replacing a quote, I think it'll freak out. But anyway.
Oh, there. Sorry, I didn't see that one.
That's what I meant. That's what I meant.
I thought you meant the space, the %20.
No.
Okay.
Something automatically URL encodes everything, but
Yes.
Then
we're going to do -O to say where we want it to output, and we're just going to dump it in temp rev.php. And that didn't work because I think we can't use, this is where I use system instead of your popen. Oh shit, I know what I did. I didn't give it the port number. There.
Yeah, because I used popen to do it.
There we go.
System returns the PID of the thing that spun up.
Yeah. But yeah, once we get the command right, we can see that our target hit and got our rev.php file. Now that it's on the box and ready to be executed, we set up a netcat listener.
Can you use a Linux gamer said, can you use a post command or have to use wget? So in this case, on the web server he's on, there isn't the ability to post files to the server. So sometimes we'll do CTFs where part of the vulnerability is that the server has an arbitrary file upload, and you'd upload a PHP file. One we did a few weeks back had that. I forget what it was called. But this one, we can't upload files. So instead, what we've done is we've got command execution on the server shell via the server itself. And so on the server, we're saying, go pull this file from a server we control, and then we can go from there.
Yeah. And we know that the temp directory pretty much always has write access for us. So the post request would be if we were sending data to the server, but the way that we're doing this is we're telling the server to pull the data from us.
Yeah. It's a bit like instead of a reverse shell, it's a reverse file transfer.
Yeah, you could look at it like that. Yeah. So now that the file is on the box, we set up our reverse shell listener, which I've told mine to be on port 443. And again, we just sort of update this command to, instead of try and get that file, we're just going to tell it to run php/temp/rev. Hang on, what did I just click? There, rev.php. So
the interesting thing is we're not using the PHP reverse shell in the normal way you do it. So there is a web server that is running PHP on the spots on port 80. And we could have put it there, but you'd just be running as www data rather than this server on port 999, which is running as Sacket. Yeah. And so we could have uploaded a Python script and used Python or any number of other things, but this was because Jake had already done the reverse shell as the other server, like navigating to it in the other server. Yeah. And it's like, actually, we might as well just directly run the PHP command line and get our reverse shell that way. But you could have done it with Python, could have done it with a bash script, I guess, or anything else.
Yeah, so that's why in our GoBuster earlier, it actually came up with rev.php, because I dumped it in the var www.html directory, and I just browsed to it straight from the port 80 site, but I ended up getting a shell as www.data, which didn't really give me access to anything useful. And knowing that this web app is running as the user Sacket, we sort of had to try and get this reverse shell running from this Tornado web server, not from the Apache web server. So that's why I ended up doing it this way, and mostly because it was an easy reverse shell that I knew would work, and I couldn't get a one-liner reverse shell to work in here for whatever reason. But yeah, now we are on the box as the user Sacket. Looking at his home directory and all that kind of stuff, there is an SSH folder, but it's empty, and SSH isn't listing on the box. We try our standard sort of sudo-l, looking for can this user run stuff as sudo. There's nothing in that bash history, is just my bash history from being here. It's actually empty the first time you get on here. We do a few other things, like we look for sticky bits or randomly installed applications and things like that. We can look in like the optional folder and all that kind of thing. But nothing really jumps out until we start to look for something that we have actually done in the past as well, and that is capabilities. So when we try and run getcap on the box, we see that it can't be located because it's not part of the current path environment variable, because it sits in user sbin, and our current path, if we echo that, it doesn't include sbin. But that's all good because we can just call it directly. And the way that we use getcap is we are going to try and we're going to recursively traverse the entire file system and then output any errors to devnull. So it's a lot like our find from last week that was looking for sticky bits, but this one's just looking for capabilities.
Yeah, so one of the interesting things, well, I always say one of the interesting things as if it I don't know, it's just the way I say things. Anyway, thinking too much. So capabilities were the next step on from sticky bits and needing to be root, and even to an extent sudo. The idea is that you break down kernel functions. So the kernel is the very special area of the operating system that does all the dangerous things. And in this case, the capability is capsys ptrace, and that is a particular subset of kernel functionality relating to debugging processes. And so if you give that capability to a binary, it lets the binary use those kernel functions without having to be run as root, basically. But it's only able to do those things. So, there's tons of capability. So as you can see, right at the bottom there, you've got audit control and a bunch. If you scroll all the way down to
there's a ton
sys,
of capabilities.
yeah. Not that heavily used as far as I've seen. Most places I've been just use like default builds, and I don't worry about trying to do any of that. And I guess it's really only useful for adminning a box. If you're running an app, it's probably not super critical. But this ptrace one effectively lets us debug applications running as any user with all of the fun things you can do with debugging. So normally to debug on Linux or Windows even, I think, you can debug a process that you're running, and at worst, you're going to be able to abuse something that you've already got access to. But if you combine this with debugging an app running as root, because this will let you debug an app running as root, we could do some interesting things.
Yeah, so you can see when we even just Google for the capability, so looking through this list, we've got a bunch of different things with various different capabilities. And the one that sort of instantly jumps out is the fact that Python 2 has this capability, which it normally wouldn't have. So
should clarify, that's why I focused in on that one.
Yeah.
I was jumping the next step.
Jumping a bit ahead of us, but it's fine. So when we Google what that capability is, just to look up what it is in the man page, we can see that the second result is how to privesc using that capability. So because that's exactly what we want to do, we're going to look at this and follow along with another little guide on how to hacks. But basically this sort of runs through, and again, it's a very similar example to what we've got going on our target machine. So they've got the same capability on the same binary. And so we are just going to follow the same set of instructions that this thing does. So running the PSEAF is just going to give us a bunch of data about all of the running processes on the box. And the idea here is we're just looking for a process that's running on here as root. So we can see in this first column, if I scroll up a bunch, it should tell me that, this is the user ID, the process ID, and a bunch of other data, the command and stuff. We're just going to look for an interesting running command that is also being run as root. And looking through this list, we come across, let me find it in the list. It's down the bottom here somewhere. Not that one. That one. So we've got Apache running a few times on this box. We've got it running as www-data a couple of times, actually a bunch of times. But then we've also got Apache running as root, which is probably a bit, again, gamey for the CTF, because I doubt you'd ever see that otherwise.
But there is, I guess, something in finding a suitable process to do what we're about to do it to. Otherwise, I don't know, when you're dealing with some of the root processes, you might actually make the box unstable. If you were mucking around in someone else's live environment on a pen test, or if you're like red teaming, blue teaming, and you're blue teaming, someone crashing some system process by doing what we're about to do would raise some eyebrows. So finding a suitable process to do what we're about to do would be the thing.
That's exactly right. And because, like you said, this is more about injecting stuff into memory and then jumping out again, or, running traced information on a running process. So we can't necessarily just dump in a reverse shell and execute it. We have to set up a bind shell. And this kind of runs through and explains in a bunch more detail about what's going on. But it gives us a handy dandy little proof of concept script that we are going to use. So because paste and all sorts of things can be a bit jank over a reverse shell, we are going to again create a exploit.py script, sure.
I like it how we use a quick guide we found because we're like, right, this is 90% of what we do. We just go, okay, here's this thing, how to hack this thing. And then you find a quick guide, and then the quick guide uses somebody else's proof of concept code to like.
It's interesting, right? It's that kind of line between what's being a script kiddie and what's not. Like
Yeah.
we know that we're on the right path because, I mean, it's pretty obvious that everything looks exactly the same as this guide, but at the same time, we can sit here and read through exactly what this thing does, but we can also just kind of trust that it's going to work and be a bit scripted.
Well, I mean,
why not?
I did read through it.
Yeah,
so
exactly.
It's all it does is effectively, so normally you don't assign debugging capabilities to Python, but Python can load a bunch of libc kind of bindings. I think is what it looks like. You create a structure that can receive all of the debug data when you attach to a process. And then all it does is it finds the instruction pointer, dumps in the shellcode at that instruction pointer, does a bit of cleanup, and detaches from the process to let it continue. But of course, what's going to happen is our shellcode is right where the instruction pointer is because that's what the script sets up, and it'll just run the bind shell. And then bind shell, so the shell code you can inject, you can either do it via Metasploit. There's a whole bunch of stuff on how to do that. You can try writing your own. So you'd write a little bit of C or assembly and then compile it, which I think we've done before once or twice.
Yeah, we'll go through that in another one, I think, when we actually get around to needing
but normally,
to write code for stuff.
Normally when you're doing this sort of stuff, you just kind of go, oh, is the fastest thing. I'll just drop that in.
Exactly. Especially like for us, after spending hours just trying to kind of poke around and play with things and trying to get stuff to work, we end up just going with, well, if this proof of concept works, then that's kind of good enough.
Yeah. It's like the basic building blocks of how you do these things. And then really it's just learning what to search for and learning, I've seen this before, this is the approach we need to take.
Yeah. So we shamelessly steal this guy's reverse shell Python script and do exactly the same thing. I copy it locally, host it on my simple web server, and then over in my shell, I just wget it over into temp. We're looking for Python, and we see that it doesn't have Python directly, which means it probably has it installed as Python 3, which it does. So now we want to just run that as, actually, let's just go into temp. So Python 3 exploit.py.
I think we want to run 2.7, mate.
Yeah, I know we do, but I'm running through my process.
Oh, you're proving the point, right? Yep.
So this script fails with Python 3, so we want to run it with Python 2, which, as you said, if we look up Python 2, it's also got that in a separate binary in the, well, actually, we knew that from earlier, I guess, as well, but it doesn't matter. Anyway, this script only works in Python 2, is more what that was supposed to prove. Python 2 exploit.py, if I can type. And reading through this, we actually need to pass it the
process ID, yeah. There's the sysarg vline, which is in there somewhere.
It's in here somewhere. But yeah, basically it needs a argument that is the process ID, and I'm just going to assume that it's the same as it was when I did it earlier. And so my process ID was 945, and that comes from this middle column here. So hang on, while I'm here, I might as well do it right here.
There is no 945, so it's changed process IDs.
It has two, so it is 4954.
4954, yep.
So now we let that run, and it said that it's injected its shellcode. And the way that we can test this, and they even say that in here, I think, as well, is we can run netstat again and just look for our listening port. NLP. I think we did that earlier. We got netcat and netstat.
Yeah, I was like, when we were doing a bit of a lunchtime thing, and I was like, why is my netcat not working? It was because I was using netstat arguments for netcat because I'd had one of the biggest brain farts I'd had in a long time.
And so this says that it creates a open port on 5600, which doesn't look like it's done, but that's okay.
The other simpler way is just to netcat straight to that port, see if it's there.
Yeah, it's probably because I didn't restart the box before the stream and it was already running. So rather than be a reverse shell listener, instead of the NLVP that we normally run, we just run NV, and we're going to connect to, this is the target IP address that we're going to connect and the target port that we're going to connect on.
It's not too dissimilar from just Telnet or SSH at the end of the day.
It didn't work because it's not listening. So
probably because you should have restarted the server.
Probably because I should have restarted.
Or do what I do and just like re-download the image and start from scratch.
Yeah.
Again, nothing like a live demonstration.
Yeah, well, it's kind of my own fault, really.
So if you try, maybe check the process ID and try and run again.
I mean, we could try injecting it somewhere else as well. It's not listening on that port, so it shouldn't have any problems.
Yeah. What's a suitable process that root is running? I mean, it's running Python 3, which is probably that other server.
Oh, no, that wasn't root. That was the SACIT.
Oh, the SACIT. Yeah, my bad. Oh, that's, unattended shutdown, sorry.
Yeah. Hey, it's Gloomy.
Hey. This is the advantage of it being Apache.
What's that? Oh, that there's a bunch of different Apaches running.
Well, it was easy to go, let's just do that one because we know stuff won't break.
Yeah, true. Hey, I've been good. Yeah. It's been a long time since I've seen you around. How you been doing? Sorry, just distracting. Trying to do two things at once.
5637 is running as root.
You reckon 5637? Okay, let's do that.
Yeah. 5637.
Okay. That's good. Yeah. Miss your voice too. Sorry. Python 3.
Now he's caught up in the chat.
Python 2, yeah, I'm catching up on chat. Sorry, what was that number again?
5637.
All right, let's try it on that. Okay, cool. We've got some code. Let's just screw it. You know what? Let's just run this. Did it work? I mean, it worked better than it did last time. And if we do a who am I, we are root.
Nice.
We did it, guys. We're not making anything, so we're hacking into a deliberately vulnerable machine, and we actually just finished. We own the box.
What a fun journey, though.
It was a fun journey. It was a very unprepared journey.
Yeah, like it's funny how some weeks we have them prepared in advance, and others it comes together at the last minute.
This was definitely one of those ones that came together at the last minute. I think it was like 1 or 2 o'clock this afternoon that we actually got root, and then because all three of us had different steps of the process, combining the write-up ended up having a few mistakes in it, but that's fine.
We got there in the end.
We got there in the end, exactly. So
Yeah.
now we're on the box as root. We use Python to just upgrade our shell from sh to bash, so we get a couple of extra niceties. But there's no flag or anything on this box. We just kind of use the who am I as proof that we owned it.
Nice. Oh, we did it.
We did it. That's it.
All the way from like the box hinting at dig to abusing debugger.
Now we make it 1 Bitcoin. Except it's running on my computer as a VM, so I'm not going to make this one 1 Bitcoin.
This is like a shortcut buffer overflow, right? Normally, where we've done buffer overflows, you have to sit there and go, okay, where in memory does this thing drop? Okay, what's the maths I have to do to make sure this gets in the right place and that we get the right jumps? And then this is just like, screw all of that. Just where's the instruction pointer? Dump shellcode. So if we go down, so if we start at the shell,
ptrace gives us all of those like registers and values and stuff. So this script is just a fancy way of going, where am I? Where can I safely inject some shellcode, and then where can I just update everything else so that it'll still run in the background?
Yeah. So it's like attach the process, retrieve the value stored in the registers into that class up above, and then it's get the instruction pointer and then just byte by byte dump it into memory at the instruction pointer for the process that we've attached to. Yeah. Like we're some sort of parasite.
That's basically what we've done, yeah.
And then you modify the instruction pointer to jump in at the right point. You reset the registers by just with what you've updated, and then you just attach, and the thing will keep running.
So sneaky.
So this is, I guess what this is they're called capture the flag. So the idea is someone will produce Gloomy just asked like kind of what we're doing. It kind of is hacking for the sake of it. There's some learning. We used to do a lot of this a while back, and then we stopped for the better part of a year and got busy with work. And so we thought we'd start back a little bit easier. So the intent is to learn as we go, and sometimes new things pop up. Sometimes it's, oh, right, that's how we used to do it. But the idea is it's basically like a puzzle, right? Like an escape room, but the opposite way around. You're trying to break in.
Yeah, exactly. And so we source these deliberately vulnerable virtual machines from a place called Vulnhub. And, you know, there's thousands of these things of varying difficulties. And, you know, people make these for the same reason. They make them to learn themselves, or they make them just to try and challenge other people. And, you know, you're free to download these and then just try and hack them with no consequence. So it's a bit of practice. It's a bit of everything.
Yeah, it's a bit like a code escape room.
Code escape room works.
No, I couldn't send to Rediv to save my life. It'd always end up at least 3 EMs off for whatever reason. 5700 Gbox for VMs. Nice. I have a crappy little Intel NUC that I run ESX on for mine.
I just run them both straight on the same laptop that I've.
Yeah. Hence his laptop having a seizure in the stream.
Yeah.
Yeah,
it's an entry room, exactly.
Yeah. Cheers, everyone. And I should say the write-up was written by the ever helpful Mark or Mork Walker, who stayed silent.
He has to decipher our terrible notes, which if you've seen any of our streams in the past, my notes can be terrible, and he turns them into a beautiful write-up that we can follow and everyone else can follow.
His notes are like the mathematical equivalent of, so 1 + 1 = 2, therefore solve a quadratic equation. That's what his notes are like. It's did this other thing.
So beautiful.
Blah, 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 got root. And you're like, how did you get root from there?
Yeah. I'm very bad at taking notes at the time, and I very rarely go back and fill in the gaps either. Is a lot of my problem with my note taking. Only for CTF, like for pen tests and stuff, I'd take very.
I've been mostly able to read between the lines, I guess, to understand your notes and follow through. most of the time.
Oh, good. Anyway,
This one I would say was like easy to medium. Yeah, you could say solve. It's like a puzzle. So this was an easy to medium, I would say. It's been a while
yeah.
since we've done CTFs, so um, we're kind of working our way back up the difficulties. We've done a few really easy ones in the past couple of weeks, and this one was slightly harder, I would say, than those ones. We definitely had to spend a lot more time on this one than the previous ones.
And Linux Gamer just referenced the old coffee cup holder that used to come on PCs. I think I'm sure you can find it if you just search for Bastard Operator from Hell or BOFH. You'll find like just tons of little like asides like that, just old school IT admins in the 90s finding users doing stupid things. Geez, that's a throwback.
Yeah.
Yeah, sweet. I'm gonna make sure that I think I'll make sure this one gets to YouTube, and I'll put last week's one on YouTube as well.
Yeah, okay, no worries. Thanks everyone for, I don't know, the likes and follows and the comments in chat. It's good to talk to people while we do this stuff. It's good to see you again, Gloomy.
Yeah, I guess we should probably get better at if you've got something to say in chat, we do keep an eye on it.
Yeah, you said Mr. Hacker, Mr. Robot was a good one, so I might try that one next. I don't think I've done that one in the past. There might have been, unless it's the same as the Mr. Robot that was on Hack the Box. I think we've done that one, but I mean was a common TV show, so there could be more than one CTF with the same name. We'll take a look at it, and maybe, who knows, it might be next week's, it might be in a couple of weeks. We've got sort of a few that we do in the background just in case some of the harder ones don't get completed in a week, because we're all quite time poor and don't usually get around to them very quickly.
Normally, it's like 3 days before. Hey, have we got something for this week? No. Oh, well, let's do something.
Yeah. But yeah, that was it for this week. Thanks for coming along. Hope to see you all again next week.
Bye.
See ya.